Welcome back and welcome to section 4, scaling your DynamoDB application, auto-scaling, global tables, and DAX. Welcome to video 1, the unit of performance in DynamoDB, provisioned capacity units. Let's briefly revisit what DynamoDB is, and this is important to get the context for the rest of this video. DynamoDB is a fully managed NoSQL database. So what that means is we don't have to worry about infrastructure, networking, servers, even virtual machines. It's not something we run on Amazon EC2. It's not something we have to host ourselves. It's not something we have to patch or upgrade or roll new releases to or anything like that. It's the closest thing that we can get to database as a service. So as we've seen with DynamoDB, the only interaction that we ever have with it is via an API. We never stand up infrastructure, we just call an API to send our data and to get our data back again. We never have to think about servers, we never thought about operating systems, we've never said we're going to run this on Ubuntu or Red Hat or anything like that. We've never made any consideration of networking, it's just something that we call over the internet. All we've done is configured the service and then consumed it directly via an API. Now under the hood, Amazon obviously needs to be able to manage capacity for each user's table, and then of course we have to pay for that. So they need to be able to bill for usage of that table and figure out how much DynamoDB we've consumed. So there are a few fundamentals around scaling that you should know about. And the way DynamoDB is provisioned is through capacity units, and there are two types of capacity unit. There's the read capacity unit and there's the write capacity unit. A read capacity unit is obviously the amount of read capacity you provision against your table. And this also applies to indexes. So remember we talked in the previous video about global and local secondary indexes. You need to apply read and write capacity to each of those indexes. And write capacity units, just like read capacity units, reference the amount of write capacity you provision against your table. And these also apply to indexes. And the last consideration is storage. Now this is not something that you have to configure in DynamoDB because Amazon manage it and scale it for you transparently. But the maximum amount of storage you can have for a single partition is 10 gigabytes. And this actually leads us to have an understanding of how Amazon build DynamoDB and how they provision it. So each partition is actually a node in the database cluster, and each of those nodes has 10 gig of high performance SSD storage. So firstly, a little more about read capacity units. If you decide to provision capacity yourself, you must choose how many units you want to allocate to a table. One read capacity unit represents one strongly consistent read or two eventually consistent reads for an item of up to 4 kilobytes in size. If the item is larger than 4 kilobytes, additional capacity units are consumed. Transactional reads consume 2 read capacity units for items up to 4 kilobytes. So you're charged a penalty of double if you decide to use a transactional read or a strongly consistent read. Read capacity units refill every second. So one read capacity unit gives you one strongly consistent read of a 4 kilobyte item per second. Now write capacity units work in a very similar way. One write capacity unit, or WCU, represents one write for an item up to 1 kilobyte in size. If the item is larger than 1 kilobyte, as with RCUs, additional WCUs units are consumed. Now transactional writes consume 2 write capacity units for items of up to 1 kilobyte, and again, WCUs, as with RCUs, refill every second. So one WCU gives you one strongly consistent read per second. Now a key thing to note is the maximum allowable item size is 400 kilobytes. Writing one item of this size per second would require 400 WCUs. So do keep that in mind when you're writing to your DynamoDB table. Now our load on database tables is not always linear or predictable. So DynamoDB allows you to temporarily burst beyond your provision capacity. DynamoDB works by retaining up to 5 minutes of unused capacity units for you to use. And you can think about this like a bucket that refills but can only hold 5 minutes worth of capacity units. So for example, if you have a table configured with one RCU and the table remains idle for a 5-minute period, at the end of this period you will have accumulated 300 RCUs which are available in a rolling window for burst capacity. Remember now that DynamoDB is a distributed system and your provision capacity is distributed across all partitions in a given table. So let's say you've provisioned a table with 400 read capacity units and 400 write capacity units, and that table has 4 partitions. Each partition will be allocated 100 RCUs and 100 WCUs. If more than 100 RCUs or 100 WCUs are consumed on a given partition, it's going to start to get throttled. Now this is called a hot partition scenario, where read and write load is unevenly distributed. So Amazon have recently introduced a feature called DynamoDB Adaptive Capacity. And with adaptive capacity, Dynamo attempts to alleviate this issue by dynamically reallocating provision capacity to hot partitions. So we can see in this diagram, we've got 4 partitions. We've got a total provision capacity of 400 write capacity units, a total consumed capacity of 300 write capacity units. Now, on the first 3 partitions, we're only consuming 50 write capacity units. But on the 4th partition, we're consuming 150 write capacity units. So we're writing in an uneven partition pattern. So partition 4 is getting hot. So what DynamoDB will do within burstable constraints is it will provide additional capacity on those hot partitions to alleviate constraints. The last piece of the puzzle, of course, is the pricing model. So you pay for provision RCUs and WCUs as well as consumed storage. And these are the prices for EU West 1, which is Ireland. So you pay $0.000147 per RCU per hour, which is about 10 cents a month, or about 53 cents per month per write capacity unit. On top of that, you pay just almost 30 cents, so 28 cents per gigabyte per month of storage, and the first 25 gig is free. So that's everything I want to talk about in this video.